Okay, so the basic tools of astronomy is the subject of the next few lectures. So how do astronomers get information about what's out there, what its structure is, and how it's moving and so on, is through light. And so let's imagine that we have, to make contact with our previous lecture on the hydrogen energy levels, that we have a hydrogen gas. So here's a gas with hydrogen, so it's H, and this gas is excited in some way. So we give it energy, and there are transitions in the nuclei. The electrons go to higher energy levels, and then they come back down, and they transition from one quantum number, one n quantum number, to a lower one. And what you get, if you look at this, is a spectrum, is the spectrum of hydrogen, which looks like these lines. So we calculated the energy, the delta E, associated with different transitions, and we got a bunch of different values. And so you would see a line like this for different values. So maybe we can show this from a textbook. Here is, let's sort of focus in on this a little bit. I want to show, so here is the spectrum, right? So you actually see red light here. Let's focus in a little bit more. And here are the n, here are the transitions, right? The n values, 5, 4, 3, 2, 1. And we found that from n equals 4 here to n equals 2, we got an energy that corresponds to the visible. And so the same was true for n equals 3 to n equals 2, I think. And so these two, which here are calculated in terms of the wavelength, 486 nanometers and 656 nanometers, are right here. And see, these are the two visible. And then the higher energy ones are here, and those occur, see, 434. Where's the 434? 434 is from n equals 5 to n equals 2. According to this, I think that's still part of the visible. I forget what that is in terms of frequency. But those are the different lines. So that's the kind of spectrum. That's an emission line spectrum telling us the kind of object that's there. So we look at objects in space and we see these kinds of things. We know there's hydrogen there. So let's focus back out again. Okay, so that's sort of an emission spectrum. Emission spectrum gives us the signature of the light, of the object that's producing that light. But let's imagine that we have, I don't know, stars or a galaxy or something that's shining in all sorts across the electromagnetic spectrum. It's producing light across the electromagnetic spectrum. And we have our hydrogen gas that gets excited by this light, and then we observe this. So the hydrogen gas is between us. The hydrogen will absorb only the specific energies associated with the energy levels of hydrogen, and then we'll radiate them. So here, here's an atom of hydrogen that absorbs energy and then re-radiates it, in all sorts of directions. And so what tends to happen is that all the light, most of the light, gets through. It's not absorbed by hydrogen because the hydrogen absorbs only specific delta E values, and then radiates them mostly in other directions. And so you'll see a spectrum which has light sort of everywhere except. So I'm trying to draw these are the same locations as these, but you actually don't see anything there, so it's dark, right? Because nothing's being generated, no light is arriving at that frequency because it's absorbed and then scattered or re-radiated in other directions. And so you basically see this. This is all light, all light. We assume there's a continuum of light there being generated, something like that. So let's look at that in more detail. This is called an absorption spectrum because you're looking at you can tell that there's hydrogen there, but through the absence of those lines as opposed to an emission spectrum. So let's focus in on the same text and see this kind of spectrum. Okay. So here it is. And so here are the same lines as we see in the emission spectrum, with the difference being that there's actually no light there because it's being absorbed and re-radiated exactly at the frequencies associated with the element hydrogen. But you see all this other light there, right, coming from somewhere else. And so the next thing to do is we recognize that we have a spectral signature that tells us what's out there, what's emitting this light, and then we'll see that as the stuff moves around, these spectra, both emission line and absorption line spectra, will start to move as a result of that motion. This is the result of called the Doppler effect. And so the way they move, well, we'll still be able to identify the elements because they all sort of move together one way or the other. We'll be able to tell not only what's there, but how fast it's moving.